The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseware continue to offer high-quality educational resources for free. To make a donation or to view additional materials from hundreds of MIT courses, visit MIT OpenCourseware at ocw.mit.edu.
Okay, so to begin, so in the last class, we talked some about some of the early documentary films. The films by Nanook of the North by Flaherty and Man with a Movie Camera by Dziga Vertov. And in today's class, we're going to be shifting a bit and thinking a bit more about the question of the relationship between documentary film and science. And one of the things that many commentators argue often links science and documentary in terms of people's common perception of it is that there's often a tendency to think of both of them as sort of offering unmediated access onto the world out there. Right? So there's often a strong tendency for people to see documentary as simply a window onto reality rather than being an interpretation of the reality that's out there. And certainly that's the case for science in an even stronger sense, that for many people the idea is that they like to think of science as allowing completely direct access to the outer physical world. But many science studies scholars would argue that science doesn't just simply offer unmediated access onto the world. How do scientists measure or monitor or present the natural world? Often they have to do so through technical instruments, right, for example. And those instruments serve as a form of mediation. And when scientists use those instruments, for example, or they might use visual pictures or diagrams based on what those instruments might say, those visual images also have to be perceived or interpreted, right? And this is increasingly the case given computer simulations. So for example, I have a student who's working on the issue of uranium mining. And it used to be the case that when geologists went off to do work on uranium mining, they would go off and do actual field work at geological sites, and that would be the basis of their work. But now increasingly, geologists are relying on statistical modeling to find out where they think that uranium deposits might be, for example. So there's an increasing way with the use of computers and visual modeling that visual images and diagrams and pictures become increasingly central to how science gets conveyed or talked about or thought through. So if you think about those visual images, you always have to, how are the visual images constructed? How do people interpret those images? How do they think through them? So there's all these kinds of layers of interpretation and mediation that happen through those kinds of visual images. And then for scientists, when they want to talk or write about their work, or they want to convey it to others, we have to do it through speaking, right? We rely upon the language that we use. And there's certain conventions then about, well, how do you write up the science that you're engaged in doing? How do you persuade fellow scientists that this is a good argument? What are the conventions within your discipline about what makes a good or convincing argument? So all of these different kinds of representation and language help to mediate how we perceive and understand the world that we're part of, in addition to whatever our own personal kind of social positioning or institutional positioning might be. And similarly, documentary film theorists would argue that documentary film also doesn't offer just simply unmediated access onto the world. I mean, documentary films are about the real world, but they're also interpretations of what that real world is, right? So, and again, it's not to say that some interpretations aren't better than others, because some interpretations are better than others. But filmmakers do, I mean, obviously filmmakers choose their subjects. They choose what to shoot. They choose what to exclude from the frame. They choose how to create a narrative out of those images through the process of editing. And then you also have the issue of, the subjects that documentary filmmakers are filming. What are those subjects' interpretations of the world? And then you have the people who, at the end, view the film, who have their interpretations of what they think is going on. So you have the subjects who are being filmed, their interpretations and mediations of the world. You have the filmmaker creating mediations of what's going on through what the filmmaker is doing, and then you have the people who watch it at the end who are interpreting and mediating it at the same end. So you have all these kinds of different layers of interpretation that all go on as people make and view documentary films. And so in this class, I just want to very briefly talk about some social science perspectives on thinking about science. And that got referred to in your reading a bit as STS studies. And I know that article, there was a kind of an overview article that I gave you by Susan Silby, who's the chair of the department here, actually, and Sophia Ruth. I know it's a difficult article. You're not really expected to. Most of you are undergraduates except Katerina. Katerina has to understand everything in it. But for the rest of you, the point is just to give you some sense of sort of the terrain of the arguments, and you're not really expected to sort of know all the ins and outs and details of all that literature. But just suffice to say that social studies of science, it gets called by different names, science studies, social studies of science, STS, lots of other different names we won't go into, has been an interdisciplinary venture by historians, philosophers, anthropologists, sociologists, and others that gained considerable momentum during the 1960s and 70s, and it's offered a way to think about science in social terms, and right, to stand back a bit from the science and think about what it is in terms of the ideas at work, not only the ideas at work, but also in terms of the people who practice science, the communities and institutions that they're part of, and these are important social questions for us to be thinking about, right? Because you know, science and modern technologies are so incredibly crucial to our contemporary lives. They shape how we live, how we think in the world, the kinds of policy decisions that get made, the health of our bodies, the kinds of knowledge we consider valid. I mean, so these are all completely central social questions. So for social scientists and philosophers, these kinds of questions around science are also extremely important. So it's not only important for science and engineers, but it's also important for people in other disciplines to be thinking about these kinds of questions. And I just want to throw out a couple important points that science studies has made that I think it might be useful for all of us in thinking about this class. And as you think about your final projects, and you think about sort of what kind of project you want to do, it might sort of help a bit in thinking about it. So one important insight from science studies is that instead of seeing sort of, well, here's society over here and here's science over here, and they're somehow separate and in opposition to each other, that one of the major points of science studies is that you always have to see science and society as being co-produced or in relationship to each other. And maybe some of this sounds a bit obvious, I'm not sure, but obviously science comes out of our social world. It's part of the social worlds in which we exist. Science gets produced by people in particular historical times and places, and because of the times and places in which we all exist, we ask certain kinds of questions and we don't ask other kinds of questions. The time periods in which we're operating shapes what we consider to be important or not. It shapes what gets funded or not. And science, as Susan Silby argues, science is a communal process, right? For the most part, it happens through institutions. It's a collective enterprise that happens at places like MIT and through other kinds of institutions. Students get trained in particular kinds of ways. Again, there's whole funding bodies that operate in certain kinds of ways, and they fund certain kinds of issues and not others. And so we have to think of science as being fundamentally a social or collective kind of activity. Okay? And I just want to make very clear, though, that this does not in any way undermine the validity or the importance of the knowledge that comes out of science. And if anything, I would argue that it adds a certain richness and appreciation to understanding it, because there's also these whole layers of social complexity that are also part of it as well. So that's one crucial point. Secondly, another crucial point is that science studies has shifted even in its own thinking, from not only thinking about the content of scientific knowledge, but also to thinking about science as something that people do, right? And so you have a number of science studies scholars that have been engaged in laboratory studies. Well, so they go and they spend time in laboratories because they want to pay attention to science as a process. What do scientists actually do? How do they know what they know? How do they think about it? How do they learn it? How do they train their students? How does this affect the ways that knowledge ends up being produced? Okay? And so you have social scientist scholars who do work in laboratories. One of the articles that you read for today by Sharon Trawick, she's done a very famous ethnography called Beam Times and Lifetimes, where she did research in laboratories with physicists, both in the US and in Japan, which is quite an interesting study. I sometimes use it in Intro to Anthro. It's a good read if anybody's interested. And then you have other social science studies scholars that also look at scientists beyond the laboratory. So you have Hugh Gusterson, somebody else who used to teach here at MIT, who no longer does. He's at George Mason now. But he did work with nuclear weapons designers at Livermore Lab. And because it was classified, he couldn't get access to where they were actually doing the work. And so he ended up, you know, kind of lurking around Livermore Lab, basically on the outside. And so he would go to coffee shops with people, go to their houses. He would go to church. He would go shopping. And he would do these really in-depth interviews with people. And so he spent a lot of time sort of hanging out in the areas where nuclear weapons designers were, spending time talking to them. And he became, it was very interesting in his work. From the beginning, it was kind of like, well, who are you? And then afterwards, I think people came to sort of enjoy telling their story to him, because a lot of people hadn't had a chance to tell their story about what they did and why they did it and how they thought about it in moral and other kinds of terms, that it sort of became the thing to do, that everybody wanted to be interviewed by Hugh. And so everybody's like, well, you interviewed everybody else. How come you haven't interviewed me yet? So he kind of became the resident anthropologist of all the nuclear weapons folks at Livermore Lab. And then you have Stefan Helmreich, who's another science studies scholar here at MIT, who also, he did work with marine microbiologists and following them around not only in laboratories, but sort of taking a trip down in Alvin under the water, going to conferences, other places where scientists might go. So you have a number of science studies scholars doing work on what is it that scientists are doing and sort of following scientists around where they go. And so the big question from this is, how does science potentially look different when we think about it as something that people do? Do we think about science differently when you think about it as a process, as an activity, rather than simply, you know, some data that you get in a textbook? If you think about it as an activity, I think a lot of scholars who do this kind of work would argue it actually kind of opens up and frees up a lot of ways of thinking about science. And that's particularly going to be relevant for us since film is a medium that focuses on activity. So the third issue I wanted to throw out is that science studies scholarship has also been helpful in thinking about questions of science and technology as they travel throughout our social world, even apart from scientists and other kinds of folks. So the question of how do debates about science spread through other aspects of not only US society, but other regions of the world. So you can think about this question of, I mean, lots of different ways to think about it, but in relation to environmental pollution is one example, right? So if people live in a community that they have concerns about environmental pollution, science becomes really crucial in terms of trying to figure out, well, what is the nature of the pollution? What is the extent of it? There might be debates about what kinds of knowledge gets counted or doesn't get counted. But for a lot of people in their day-to-day lives, I mean, science is obviously something that's a crucial part just for average people in terms of living in the contemporary world. And internationally, you think about international development. A lot of the language of international development projects uses managerial language, but also language of science and technology is part of it, right? So there's all these questions about, well, what are the discussions about science and technology in all these spaces apart from laboratories and scientists in places like MIT? How does it work sort of out there in the world? Okay? And part of the reason I think that's important for this class is, again, as you think about your final projects, we're encouraging people to do final projects around science and technology, but we also want you to think broadly about that. You don't have to just think sort of doing science in a lab, although that can be really fascinating. You know, so if you can think of a really good project you want to do based on that, that could be fantastic. But if you also sort of want to follow things outside MIT or take an unconventional angle on this, do it. You be creative with this. Think about how this stuff moves, how it goes to different kinds of places. What do people do with it? So anyway, so we want you to be thinking in those terms. Okay. So, and just once again to emphasize this point that for us in thinking of this class, we really want to be thinking about science as a process. Not only questions about knowledge as an end product, but a process of what do scientists do, how do they come to know, what are the relationships that scientists are part of, how does science and technology circulate out there, what kinds of debates are they part of, what are the implications of the debates. Now I lost my next page, sorry. Anyway. Sorry, I had file conversion problems, so I got a bit stuck here. Anyway, okay, and I think this focus on practices again is useful for many different reasons. in addition to thinking about the film angle, but also thinking of science as a kind of practice or as a process, I think also helps to make science human, right? It helps to bring sort of the human element back in and make science more approachable. And again, this is also relevant for thinking about doing documentary films about this. And it's also focusing on how people come to have, also by focusing on how people come to have knowledge, that you gain appreciation for that kind of knowledge as well as you see the limitations of that knowledge, right? When you focus on, well, how are we going about getting knowledge? What are we able to get access to or what not? What's the potential constraints? What's the things that we're really good at? Like, isn't it amazing that people were able to figure this kind of thing out? But what's the kind of stuff that's difficult to think about? That it's actually by sort of following these activities of science that we sort of get a stronger sense, and again, I think a richer sense of what do we know well and what do we know less well. And as we've talked about earlier in class, part of the goal of this class is also thinking about documentary film as a process itself. So again, we're not just looking at documentary films as a product. Right? We're not just looking at the final product. We're also trying to think about what were the contexts in which the films got made, what were the social relationships like that were part of the documentary filmmaking, what kinds of choices got made, both aesthetic choices but also choices between relationships between subjects and audiences, what got included in the films, what got left out of the films, right? So we're thinking back to the discussion we had about Vertov and Flaherty. So all of those questions would become important, right? I mean, what were the social contexts in which those films were made? Who were they made for? How were choices made? What were the relationships that got set up through the making of documentary film? So we're thinking about both science as a process, and we're thinking about documentary filmmaking as a process. And so the idea of this class is to put the two of them together, right? So thinking about the process of documentary filmmaking, thinking about science as a process, and hopefully trying to make videos and films about that, okay? The conjuncture where they both come together. Okay? And again, we're going to go back to this at the end of the class where we talk more about your final projects. But first, we want to show you some documentary films that have been made about science. And I just wanted to throw, I'm going to be tethered, so this is going to be a little bit difficult. Okay? But as we talked about in the very first class, science films have always been there from the very beginning of filmmaking, as we saw early on from those 1905 films by Charles Urban. That we discussed. So very, very long history. But we want to list some of the ways in which filmmaking and science have come together. And I just want to list 4, and maybe you all can help me think of others. But one major way has been, for some people anyway, to think of film or video as a means of collecting data, right? How can we use film or video as a way to collect data, to collect information about the world? So whether it's about using film or video to slow things down, do things in slow motion that we wouldn't be able to see otherwise, potentially speed things up. So a whole range of what can you do with these kinds of technologies that allows you to see, not only allows you to see things in different kinds of ways, but that you can actually use as data. And then there's the whole range of other things that this can lead off into in the sciences, where you have all kinds of imaging techniques, where you could be brain scans or other kinds of scans. So that's a whole other kind of using visual images as data collection. But here we're focusing on particular kinds of uses of film and video as data collecting. Another way the two have been linked is this question of how can we use film or video as a way to go out and explore the world? How can we use these instruments, these technologies, to explore these worlds, these social worlds around science, or questions that science might raise for us? How do we use them? Can we use them as tools of exploration? Okay. A third way in which they have been linked is an obvious one that's probably familiar to all of us, is education, right? And there's 2 aspects of this. One coming from the end of the scientists, and one coming from the end of the filmmakers. Okay? So a question is then, for scientists, you know, one of the main questions about film and video could be, how can we use these kinds of technologies in order to educate people about the sciences? Okay? And then one of the primary questions for the scientists become, how do we take the work that we've done and convey that in visual terms? What are the means we can use to convey this? And these are difficult questions, right? And these are also difficult questions for scientists when they write, right? Because how do you explain to other people what it is that you're working on? And often scientists have to rely upon certain kinds of written metaphors to try to explain what they're getting at. Are those metaphors, I mean, and do the metaphors, I mean, they never quite exactly work, right? I mean, and so one of the questions that scientists always have to think about then is the metaphor that I'm using, is it helpful, or is it potentially leading things astray? Okay? And the same kinds of questions then when scientists want to use visual technologies. When you're using film and video to try to educate people about the sciences, what kinds of visual images or narratives are you going to use to try to convey that information? And what's the potential, you know, benefits or constraints about the way that you choose to do it? So that becomes a major question for scientists. For filmmakers, one of the major questions becomes, well, what kinds of narratives can you use to talk about the science that are going to keep people interested? Right? I mean, so their goal also has to be, how do you make something interesting that people want to see? So it becomes this, well, what interests people about science? How do I convey something in a visually interesting way that tells a story in a way that will bring people in, they'll want to learn more about the science? Okay? So these kinds of questions about how we use film and video as means of education. Okay? And then also there's, you know, certainly within popular culture, there's also just a lot of fascination with science, right? So then there's also using film and video technologies as a way to satisfy popular curiosity about science in a way that might not quite be strictly educational. So again, we talked to them about, you know, sort of the IMAX films, and they might be somewhat educational, somewhat entertainment, but in a way that satisfies sort of public curiosity about the sciences. Okay, and so first we're going to think about all of these a bit as we watch various clips tonight. And the first one we're going to think about is using film and video as a technique for generating data. And we're going to be doing this through the figure of Doc Edgerton. Do any of you know who Doc Edgerton was? Anahita?
He has a center here.
Sorry?
He has a center here, right? The named after him.
Yes.
Yeah, so Doc Edgerton was, he trained here. He was born in 1903. He died in 1990. He was a legend.
In the MIT faculty club.
Did he really?
Collapsed and died, yes.
Really? Oh,
in
that's
1990, yes. Anyway.
Wow. He had been a faculty member here at MIT for 40 years. He had been here as an undergraduate. He went off and did research at GE, I believe it was, for a few years, and then he came back to do his PhD here at MIT. And he became interested, he was working with motors. And one of the things that he noticed when he was doing his work, that when there were problems with electrical transmission lines and the lights would flicker, that he could observe changes in the motion of the motor that he couldn't otherwise. And so what he ended up doing during the 1930s was he developed a repeatable short-duration electronic flash, or a stroboscopic light, that could reveal motion in segments. So you could capture fast motion in a way that was not accessible to our normal perception. Okay? So he did, I mean, I didn't write it down, but I think it's in here, exactly how it worked. So Edgerton called his unit a stroboscope. It could emit 60 10 microsecond flashes per second, a hitherto unimaginable speed. Okay? So through his invention, Doc Edgerton was able to capture things using photography. So he did both still photography, but also obviously if you do still photography that quickly and you run it together, you have moving images, right? So this is also sort of the intersection of photography and moving pictures. So he did this fascinating work where he did extraordinarily famous work, again, both in still photography and in moving images. I'm sure many of you have seen his, even if you're not aware that they were necessarily Doc Edgerton's work. His work became extremely famous. He actually, there was a short film that was made about his work. I think it was in the 1940s that won an Academy Award. His work was shown all over, and it also crossed the boundary between science and art, where some of his work was just seen as so gorgeous that it was shown in museums as artwork. So he was kind of working on that boundary then between the world of science and the world of art. He also did other things as well with a couple students from here at MIT. He became involved during the Second World War in classified military work. So they did work on inventions for aerial reconnaissance, aerial photography. And then also later they did photographic images of nuclear weapons blasts. And there's actually some online. You can actually see them if you're interested in that. He worked with Jacques Cousteau, helping Jacques Cousteau develop underwater camera equipment. So he was an inventor. He was a scientist. He was, some people would call him an artist. He said, "Don't make me out to be an artist. I'm an engineer. I am after the facts, only the facts." But what his work, I think, suggests for a lot of people is can work that is science also be art at the same time? So anyway, so let's watch a few.
So yeah, I don't know
his
which ones you want to
pieces.
watch. You should drive.
So that was a bit of an introductory one.
Just go back.
So here's another one of his famous milk drop pieces, but this is later, later in color. And I'm sure you've seen some of his famous stills. Have you seen the one with the still photograph with the apple with a bullet going through it? Have you ever seen that image? You've seen the photograph, yeah, which he famously titled "Making Applesauce at MIT." And you might have seen this famous one of a card with a bullet going through a card, like still images that they were shown in publications like Life during their time. I mean, they really circulated widely. Let me show you a few more.
I think a couple of them are on display in building 34.
Yeah, I wouldn't be surprised because the 150th anniversary. There's a lot of interest in, and I think the MIT Museum is doing a Dr. Edgerton display right now because of the 150th anniversary. So there's probably a fair amount of stuff around right now. Hummingbird. This is really pretty too.
There's a milk drop poster in Lobby 7.
Milk drop poster in Lobby 7?
Yeah, that's right, yeah. And if anybody, has any doubt about whether or not he actually had artistic sensibilities or intentions, I mean, look at the way he set that up with the red cup, and, it's...
And even the shape of the plates.
Yeah, I know, exactly.
Completely unnecessary.
Yeah.
Oops. So this is back to one of the older black and whites. So there's tons of stuff on here. We could see a range of different things depending on what you're interested in. Do you want to see a nuclear blast? Do you want to see some of them? It's very interesting. It goes back to the very first stuff that we saw from 1905. There's also time lapse of plants unfolding the same way we saw in the very early pieces. So again, a similar kind of, you remember back to those very early pieces where they were of interest to scientists, but they were also shown in public theaters with kind of vaudeville music in the background. So they were meant to be both popular entertainment. And so, I mean, he's differently positioned with a scientific institution, but still an interest in sort of engaging a broader audience, and again, kinds of images that people, that many people found very fascinating. But there's nuclear explosions. You could see him hanging out with Jacques Cousteau. I mean, there's a whole range of different things we can look at. Oh, the pigeon is cool. Here, I'll do this pigeon one before we do the science reporter.
Just watch a few minutes.
This one we'll just watch. I think this is a half-hour episode about him that gives a little context, but we'll just watch a few minutes of it.
You are watching a swimmer taking pictures with an underwater camera. But below a few hundred feet, as the light disappears and the pressures become too great for human endurance, other techniques for photographing the silent world of the deep oceans have to be used. These techniques for deep-sea photography are our story today on Science Reporter. MIT Science Reporter. We're at the MIT swimming pool today to talk to a man who's made major contributions to the science of photography. He is Dr. Harold Edgerton, a professor of electrical measurements in the Department of Electrical Engineering at MIT, a man who is both an inventor and a teacher, and internationally famous as the father of modern high-speed photography. At the age of 28, Dr. Edgerton invented an electronic device which allowed invisible motion, much too fast for the human eye to see, such as the swing of a golf club or the path of a bullet in flight, to be frozen onto a single photographic plate. More recently, Dr. Edgerton has been adapting his electronic flash lamps to photograph another world, which is invisible to the naked eye, the world of the ocean depths. Some of the equipment designed by Dr. Edgerton for deep-sea photography is set up here at the swimming pool, and we're going to meet Dr. Edgerton and learn more about it.
Everything work all right? Yeah. Fine, then we'll have it covered from several angles.
Dr. Edgerton, that looks very much like an ordinary camera. What keeps the water out from ruining the film?
Well, this camera is like an ordinary camera, except the case acts as a waterproof case. It was developed in France by Captain Jacques Cousteau, whom I've been many times. It's now made in Japan. This, the lens, for example, comes out, and the lens is protected by rubber rings called O-rings, which seal against a surface.
Nice. Now, how do you focus and set the distance and the aperture and all those things?
Well, you turn those knobs, and you'll see one of them changes focus, and the other one changes the aperture.
Yeah. Very clever.
And this fits in through the O-rings. And that seals. Now, I'm not going to take this apart because it has this film in here.
Right.
But if you pull these two levers, the entire mechanism, camera mechanism comes out, and you can get at the film.
It's also sealed in.
It's also sealed in, and you trigger the thing by means of a pusher at this point. Release.
Unless he also took his own light along with him.
Yes, of course, every picture must have light, and in underwater it's particularly important because the sunlight does not penetrate too well, and you always want to fill in shadows.
So
and of course, in this day and age,
Jacques Cousteau's equipment was developed with Doc Edgerton in the alumni pool right over there, which is where this is shot. So it's one of those kinds of amazing things about walking around MIT campus when you start to learn more about the history and sort of everything that was going on, these spaces that we don't really pay that much attention to as we just walk around. But have you had enough of Doc, or do you want to see a nuclear explosion or something, or a plant unfolding, or flowers or nuclear explosions?
The nuclear explosions, we'll take a quick look.
Okay.
Here we go. He actually did some really extraordinary still photos just images you've never seen before of the first few microseconds of a nuclear explosion when it's still this tiny, tightly packed ball of energy and it doesn't look like a nuclear explosion. It's really amazing.
Okay, so reactions, thoughts, comments?
I think it's kind of interesting how allowing the camera to run faster lets you actually slow it down. Because I was trying to think, like, why does that work? But then it's sort of like the more frames you have, when you play them back at normal speed, it moves at a slower pace. And I just thought that was interesting in terms of like a technology standpoint.
Yes. I'm sorry, go ahead.
One of the things also cool how we look at the milk and like how it changes the surface of like the pond that it's in, and then also when we look above the nuclear explosion, like the shape of the cloud, and it's kind of like similar, completely different scale.
Yep.
Yeah. And to this question of how it works, I mean, so the description given here, synchronized with the camera so that with each flash a frame of film was exposed, the flashing light decomposed the phases of movement. This is back to when he was originally doing his original things with the motors. Decomposed the phases of movement of one of his motors into 3,000 images per second. So at that point, it was a third faster than anybody else had been able to produce. And it was fast enough that when the film was projected at normal speed, the swift turning of the motor could be studied in slow motion. So again, it's sort of how exactly it all works. Other reactions, thoughts?
This is how aesthetically appealing it is. I mean, it's very interesting to see the movement of the wings of the bird, but most of all, it's just beautiful.
Can science be art?
Well, it's a really interesting relationship between data and art, and it's something that you see continuing. For those of you who saw Tom Schilling's piece that he made for our last class that was shown last week at the museum, one of the things, among others, that strikes me about some of the AFM nano images that are in that piece is how beautiful they are. And so if you watch the piece, you start to wonder, are they beautiful because they just happen to be beautiful, or are they beautiful because the people making them and designing the machines that create them, that are these analogs to something that's real, have a bias towards making them beautiful?
This reminds me, there's a museum in London, there's a Welcome collection, and there was an exhibition, well, there was a competition on kind of imaging of bodily tissues and kind of medical imaging, and the competition, and there was an exhibition of the best 15 works selected, and they were showing, tissue with cancer and all sorts of very intimate, kind of horrible details of disease, but it was like an aesthetic competition. These were selected for their aesthetic qualities, and it's kind of incredible. So you're walking through the collection, and you didn't really know what you were looking at and how you were supposed to relate to it.
I think the Koch Institute is doing something similar with their lobby display area. They've had a competition of bioimaging, and it's being judged on certainly not just scientific merit, but beauty and aesthetics.
And I wonder if it is a shift that's happening more broadly, whereas I think, a few years back, when people were trained, I think there was sort of a strong bias that sort of, if you had tendencies towards those artistic directions, that somehow undermined your science. And you kind of had to choose. You couldn't be one or the other, or you weren't seen as being credible in one realm if you were seen as being, credible in the other realm. But I wonder if that is breaking down a bit with the kinds of new imaging technologies that you have, which are incredibly aesthetically pleasing at the same time. And I wonder if it's sort of a similar kind of moment where maybe sort of the art and the science are kind of coming together in a way that maybe hasn't been true in more recent years.
Well, I think besides the beauty of it, it also kind of strictly refers to how this specific technology is used, the relationship between science and violence. We're watching a weapon of mass destruction and how exactly it works. It's beautiful, but essentially it's historically science and technology are developed to serve the military purposes and the violence. So I don't know, it was a little disturbing.
Yeah. Well, so there's both flowers unfolding and hummingbirds in flight, and there's also nuclear detonations. Right? So there's both ends of this, and then there's the questions of, as this stuff gets turned into art, are you aestheticizing things like violence? And that's partly the question you were raising there too, and it's things like sort of cancers on people's bodies, right? I mean, is that something that's properly aestheticized or not? How are you supposed to relate to those kinds of images? Is it appropriate to look for beauty in certain kinds of images when they're images of violence, for example? So that raises a whole range of other kinds of questions.
Which are very present in film as well. I mean, if you think about the way violence is handled in mainstream films, that's clearly an issue that you may or may not be concerned about, the aestheticization of violence. And it's something that comes up in documentaries as well.
So, any further thoughts on all this? Okay, so let's move on. So the second major use of science and documentary images that we're going to talk about today is educational, which we've already mentioned. And there's obviously long been an interest in using film and documentary as a means to educate the public about science. And as I mentioned before, one of the questions that immediately comes up from the end of the scientist is, how do you visually convey to audiences what it is that you want them to get? If you want visual media to serve as a form of education, how do you translate things visually in a way that actually will educate your audience and get them engaged with the topic? And so then the next piece that we're going to see is a film that was made in 1960 called Frames of Reference, that tries to do this in an interesting way. I'd be curious to see what your reactions are. It was made by Ricky Leacock. Ricky Leacock had studied physics at Harvard, and he later became a documentary filmmaker, an extremely famous documentary filmmaker in the direct cinema tradition. Actually, if you think back in the first class, the images of primary with the JFK election, he was a camera person for that. Did a number of very famous films, some of which you might have seen pieces of. He taught here at MIT for many years. There was a film program at MIT that was extremely influential. It sort of got phased out when the Media Lab came in. But he had been a very central figure here at MIT. But this was a film that he made very early on with two other physicists, and this is before he became you know, he was obviously making films at this point, but it was before he sort of went off and became a direct cinema filmmaker. So
I think
in the early years, right before
22
the
or
process.
something when he made this, 23 years old.
Okay, so again, called Frames of Reference from 1960. Oh, and he also worked with Flaherty on something. He was like a camera person for Flaherty. Flaherty ended up doing a film about rural Louisiana, and he ended up being the camera person for that as well.
We're used to seeing things from a particular point of view. That is, from a particular frame of reference. And things look different to us under different circumstances. At the moment, things look
You look peculiar. You're upside down.
No, you're the one that's upside down.
No, you're upside down.
No, I'm not. He's the one that's upside down, isn't he?
Well, that stops for it.
All right.
Okay. You lose. He's the one that's really upside down. You better come into my frame of reference now.
Oh. My frame of reference was inverted from what it usually is. That view of things would be normal for me if I normally walked on my hands.
This represents a frame of reference. Just 3 rods stuck together so that each is at right angles to the other 2. Now I'm going to move in this direction. You see the frame at the same spot on your screen, but you know I'm moving this way because you see the wall moving this way behind me. But how do you know that I'm not standing still and the wall moving? It was the wall that was moving. Now the wall has disappeared, and you have no way of telling whether I am moving or not. But now you know that I'm moving. The point of this is that all motion is relative. In both cases, I was moving relative to the wall, and the wall was moving relative to me.
all motion is relative, but we tend to think of one thing as being fixed and the other thing as being moving. We usually think of the earth as fixed, and walls are usually fixed to the earth, so perhaps you were surprised the first time when it was the wall that was moving and not Dr. Hume. A frame of reference fixed to the earth is the most common frame of reference in which to observe the motion of other things.
This is the frame of reference that you're used to. The frame is fastened to the table. The table is bolted to the floor is anchored in the building, and the building is firmly attached to the earth. Of course, the reason for having 3 rods is the position of any object such as this ball can be specified using these 3 reference lines. This reference line points in the direction which we call up, which is a different direction here than it is on the other side of the earth. And these 2 reference lines specify a plane, which we call horizontal or level. In this film, we're going to look at the motion of objects in this earth frame of reference and in other frames of reference moving in different ways relative to the earth frame. Well, let's look at a motion. This steel ball can be held up by the electromagnet. Now I'm going to open the switch and you watch the motion of the ball. The ball is accelerated straight down by gravity along a line parallel to this vertical reference line. As you can see, the electromagnet is mounted on a cart that can move. And I'm going to do exactly the same experiment that Dr. Hume did, but this time, while the cart is moving at a constant velocity. The cart is pulled along by a string which is wound around this phonograph turntable, and that pulls it with a constant velocity. When the cart passes this line, the ball is released, as you can see. I'm going to start the cart down at the end of the table so that by the time it gets to this point, I can be sure it's moving with a constant velocity. Now, I want you to watch right here so that you will see the ball falling. I think you can see that the ball landed in exactly the same position that it did before when Dr. Hume did the experiment with the cart fixed. But this time, the ball could not have fallen straight down. Let me show you why. The ball was released. At that point, if it had fallen straight down, because the cart moves on and the time that it takes to fall, it would have landed back here somewhere. But it didn't. Now I'm going to do the experiment again. And this time, I'm going to let you watch the motion through a slow motion camera, which is fixed here. As the cart moves by, the ball will fall, and you can watch in the slow motion camera. I'll show you this again. This time there will be a line on the film so that you can see the path. I think that you can see that the path of the ball is a parabola. But all of this has been in a frame of reference fixed to the earth. How would this motion look in a frame of reference which was moving along with the cart? Frame of reference like that. Well, so that you can see what it looks like, I'm going to fix this slow motion camera so that it moves with the cart. Like this. I'm going to do the experiment again. And incidentally, I'll start it, and then I'm going to stand here so that when the ball falls, you will have something which is fixed as a reference point. In the moving frame of reference, I think you could see that the path of the ball is a vertical straight line. It looks exactly the same as it did before when Dr. Hume did the experiment with the cart fixed. If we were
moving along in this frame of reference and we couldn't see the surroundings, then we wouldn't be able to tell by this experiment that we were moving at a constant velocity. As a matter of fact, we wouldn't be able to tell by any experiment that we were moving at a constant velocity. I'm going to do the experiment once more, and this time I'm not going to stand here behind the ball as it falls so that you won't have any fixed reference frame. As far as you're concerned that time, the cart wasn't necessarily moving at all. That time, when you couldn't see the background, then I think perhaps it was harder for you to realize that you were in a moving frame of reference.
So if anybody's interested, this is available online, and it goes on. Quite interesting, lots of great little toys and experiments.
So reactions, comments? Mm-hmm.
This is a slightly random comment, but there was a speck of paint on the wall.
Yeah.
So you could see that moving.
Yeah.
I just thought I'd throw that out.
Yeah.
No, and I noticed that too. It's funny because one of the things I love about this film is that they have such great rigs and toys, and they've set it all up, and they make it really, really easy seeming. So, well, put the little screw in here, and now the camera's attached to the cart, and the phonograph turntable will turn it at a constant speed. So it all seems really effortless, and the whole rig of the guy upside down and the camera spinning around. But yeah, the speck of paint is just a little detail they missed.
Kind of looks like like one of those kind of TV chefs program. They have all their equipment. It looks really easy. So, who was this made for?
It's an educational film. It was made with grant funding, and do you know the year?
1960.
1960, yeah.
And for schools?
Yeah, for schools.
To educate people about physics.
Yeah. I think it's sort of the whole sort of idea of laying the foundation for relativity and just understanding how speeds are, objects are either fixed or not fixed depending on where the observer is.
Mm-hmm. But what it's very famous for is the beginning,
yeah.
the opening with the as you can imagine, which is quite a. I mean, so that's something to think about too. Then, as you go to think about making films, not that you're expected to put that much effort in, but they were trying to think about, well, how would you convey something in a visually arresting way to a general audience that would sort of really make the point that they're talking about, in terms of frames of reference. And I mean, it is kind of a brilliant way to get into it, and it takes an incredible amount of work. I mean, you think about how much work they put into, as Chris said, setting up all of these rigs to actually convey that. But the kind of forethought that goes into, well, how do you convey what you want to convey? If you want to educate someone about these kinds of concepts, how would you translate that into visual terms?
And the sort of way certain visual images persist. Everybody who sees this film remembers that beginning. You may not remember anything else, but everybody remembers that opening.
It's also, I think, very effective because
it is or it isn't effective?
It's effective because the first scene, because if now we see something like that, we wouldn't think that that's actual, that's real. We'll think, oh, that's just a trick. But I was confused. I was like, but it doesn't. It's really old. It can't be a trick. What are they doing?
Right. Exactly. Yeah.
I think that's because this is old, so you wouldn't expect it. But like right now, if somebody makes something, so okay, whatever.
Right. True enough. It wouldn't carry quite the same cachet today. It's true.
Well, that's why even then, I mean, they had sort of some ability to manipulate space and do composites and so on. But that's why you have to pull out and see the quarter fall and see him flip around. It's very much a magician showing you how it's done rather than just having it stay magic.
I mean, this is a very simple comment, the fact that they're talking to you and that you are at the same time encouraged to watch the film, but also watching what's happening in the film, and I think these are two different things. and it's definitely an effective educational strategy.
It's also kind of, it's obvious, but it's sort of worth saying that it's an interesting example of the camera is you. I mean, of course, they're talking to the camera, but it's also right along on the cart. Yeah. And the camera goes on the cart, and then you're on the cart. You are the camera, you the audience.
But not always, because you are a different camera sometimes. So you see
the
camera, and then you enter.
And then you become that camera. Yes, you do switch. Sometimes you're in a different camera. Yeah.
That's true. Oh, so I was going to say, it also on that point, it's also interesting that, like throughout the whole piece, you like from the after the first scene, then you start thinking, oh, I'm gonna be tricked. I need to like pay attention. You know, think about like what's happening, and I think that's also really effective in engaging the audience, and then it also just makes it really interesting. I think because you're like it's kind of like a puzzle. You have to try to figure out, okay, what are they gonna do next? Like I can't be tricked. Yeah.
Well, and you think back to Flaherty again when he was. Doing the igloo and when Nanook does the window, and he doesn't tell you immediately what's going on, you're supposed to watch and figure it out. So that's one of the things that filmmakers do use very effectively to pull audiences in, is to allow the audience to be able to discover things through the process of filmmaking without just telling them everything. Or the idea here that you better pay attention because there's going to be something going to be going on, there's going to be some kind of trick involved, or you know, as again, how do you engage your audience and get them emotionally involved in what's going on? And sometimes revealing is the way to do it, and sometimes not revealing certain things can be the way to do it.
Making it like a puzzle, as you said.
As you said, yeah, exactly, making it like a puzzle.
And then just one last thing that another very small thing that I think is cool. We talked in the first class about the plastic elements of film and all of the different things you can change and techniques you can use. And obviously there's a lot of interesting rigging going on here and camera techniques. But one very simple thing that I think is kind of effective in a good way is this prop that they have of the X, Y, and Z axis. And so to show you what frame of reference you're going to be in next, they put it on the cart, they put it on the table. And it's just a very, very simple prop. It's a very simple idea. But it really works because it kind of prepares you for the next sort of world you're going to enter as the camera. And it's just a nice use of a prop as a plastic element. You could have made the film without it, but it would have just been that much more slightly confusing as to what frame of reference you were actually in.
And so if you end up, for your final projects, end up doing a film on a project where you want to convey you know, some of the ideas behind the science or whatever it is that you're going to be doing your work on. If it ends up being a topic, some kind of topic like this, it becomes one of the questions becomes how do you convey things in a way that's both accurate and insightful and compelling to the viewer, right? So how do you be accurate to the science of what you're trying to convey? How do you do it in a way that's insightful, that allows the audience to go, aha, I got that, and that pulls them in, and that's tricky. That's not an easy thing to do, and it requires a fair amount of thinking about how you want to go about doing it. And so, okay, so this kind of educational video obviously is from the point of view of the scientist wanting to convey and to educate, and I mentioned also you have to think about these questions also from the point of view of the filmmaker. So again, from the filmmaker, how do you convey things in a way that's, and obviously, well, we're talking about that here too with Ricky Leacock. How did he, presumably he was discussing with the scientists about, the physicists about how exactly do we want to convey this in a way that's compelling. But we're going to be talking later in class when we get to Errol Morris and some of the other things about, for filmmakers making films about science and scientists, what kinds of narratives do they want to draw on, again, as a way to pull people in. So we're going to come back to those kinds of questions a little bit later in the class. But the third thing that we want to talk about in today's class, a third major use of science and documentary is to satisfy partly popular fascination with science. And again, all these things can overlap too. So the educational aspect can overlap with sort of the popular interest, in science. And again, around this question of what are some of the stories that audiences find fascinating and want to hear about science? And Chris and I had spent some time sort of trying to think through what are some of the various ways. Here's my screen. Can I have the chalk?
Sure.
I do have one. I think it's supposed to go that way.
Pull the other board down.
Anyway. So again, this question of what are some of the stories that audiences find fascinating, want to hear about science. We've talked about some of these before. There's the element of spectacle. And again, think about IMAX movies, where sort of, again, the science is a way to see things about the world in the way we wouldn't do it before, and particularly in ways that are sort of very much visually arresting and sort of, influencing people on a kind of physical level. So spectacle like IMAX movies.
Or flies juggling balls
or
of tar.
Flies juggling balls, as we saw earlier. Another narrative that audiences are often interested in is science as hero, scientist as hero. So there's often a fascination with scientists and thinking about, well, how did a scientist sort of heroically go off and discover something, for example, that had a strong impact upon the world. So that's a common kind of narrative that audiences are interested in. Another one is science as detective story. Right. Where audiences are often fascinated with how do things get figured out, thinking of it like a detective story. Some people are interested in thinking about science in terms of what's the relationship between reason and emotion. With science often, sort of stereotyped as sort of, this being solely about reason and what are the kind of quandaries when it comes up against emotion. And obviously, the quintessential example of this is the early Star Trek movies where you have Spock, right? I mean, so Spock is all about the tension between, trying to be solely about reason, but, having emotional feelings at the same time, and how does he deal with that kind of relationship? And often those kinds of quandaries get talked about in popular culture through a science figure in there somewhere. Man, there's too many chords. Okay. And then there's also an interest in sort of science almost for the bizarre, where science itself becomes kind of a science fiction about, like, wow, look at this crazy stuff that science is up to. It's even crazier than actual science fiction. It's so crazy you couldn't even make it up. I mean, you've heard that kind of line often, I think, in popular discussions about science. So a kind of fascination with science about, how strange and odd it can be, even stranger than things that could be made up. So this is kind of the list that we had come up with. Can you guys think of others? Sort of popular ways that people relate to science, or stories that they're interested in hearing about science or scientists?
I guess maybe stories that have kind of like a moral value, that maybe science discovering something causes you to question the morality of it, or whether it's right or wrong. Yeah.
Do you have a specific example you're thinking of?
I was thinking Jurassic Park. They learn to, bring back this ancient animal, but is that right? And,
Right. So the kind of ethical issues, and the kind of ethical issues then, that issues around cloning, about sort of, oh, and actually I think we had it on the list and I forgot to put it up, but the kind of moral quandaries around sort of scientists playing God, like when is it okay
when do you
sort
cross
of
a
to
line?
push,
Yeah.
when is it okay to push sort of human knowledge and what people can do, and when does it sort of cross a line into something that is potentially morally suspect? Yeah, exactly. Where is the line that we want to draw here or not? So that kind of fascination with those kinds of stories. How do we think about that relationship, Sabrina?
Kind of like a coolness factor of personality. Like if like someone like Brian Greene in like the Elegant Universe is very entertaining. Like the person presenting it is trying to turn people up.
Yeah, that's kind of a subset of scientist as hero. Scientist is cool.
Scientist
cool.
is cool.
That science is cool. Yeah.
Science is cool. right? And a focus on, that's supposed to be as cool, if you can read that. And then also the focus on particular kinds of charismatic individuals who are seen as conveying a certain kind of image of science that people want to respond to. Anahita?
Also, I can think about some examples of science as the superior to human being or the villain, like in the movie The Odyssey, Space 2001, when the robots or the science acts against humans.
So when does science become the villain?
Right, when the science becomes smarter than humans or overcomes the human intelligence.
So, and again, that kind of question of sort of when does science become about human hubris, where it surpasses itself, and then the technology or the science becomes a danger back to humans themselves. And so, and you would see that around, in the 1950s when you think about sort of all the pop culture movies, that were, kind of veiled or overt references to nuclear technologies or other kinds of things that sort of, with people struggling with the question of when do things sort of go beyond a certain point where the worry becomes about the science itself coming back and its impact on people.
And more recently you have the whole sort of, the Matrix franchise, the Terminator franchise, which are about AI and technologies that become their own creators and then reject the human beings that created them and attempt to destroy them.
Sabrina?
Science is like a competition when you have like different people trying to do the same thing and like kind of making it seem like it's a contest.
Yeah. The fascination with, science as competition about, which becomes part of the discovery process in a way, except you've got the added element of drama with competition about, sort of who's going to, crack the DNA code, or, what were these kinds of scientific competitions about? How do people discover things? And that added element of drama.
I think linked to that is kind of science as creating history and creating the future. So a certain, like a lot of representations of kind of new things, as if the future has been brought to the present.
Yeah. I think, so science almost as a way to, for people to think about the future and the possibilities that the future might bring, or I think that happens a lot when sort of in popular cultural representations, when people think about sort of their nervousness or concerns or worries about what the future, or their hopes for that matter too, about what the future might bring. Often that future is expressed through a reference to science and technology and what it might do, rather than sort of other kinds of social issues per se. Because how do we know necessarily what the future is going to be about? But science and technology is often used to represent what we think the future is going to be. So it's the way it's the symbolic connotations, the symbolic relationship that it has to certain kinds of ideas about time, and seen as being representative of the future. Anahita?
I mean, it might go a little bit with the idea of science and competition, but also I think creates that kind of hierarchy or power relation. When you see the science fiction movie, and especially I think it's more relevant to the younger people, like feeling that, this is the scientist. Creates this hierarchy that they have all these resources and this position to be so cool, be heroes, create the future, or do all these cool things. But here I am looking at it. So it's like there's a hierarchy between you and whatever's going on.
So a kind of concern with, sort of who are these people who have this authority, who are making these kinds of decisions that I don't necessarily have input into, and sort of are they people doing this sort of for the greater good in a way that's going to help me, or is this potentially very, the decisions that they're going to make are going to be extremely problematic? And
science is power, so people who have the science are the powerful people, and if I want to be powerful, I have to have the science.
And kind of the narrative of the disconnected scientist, the scientist which is again a little like science versus emotion, the scientist who stands apart, who has this power, but who doesn't understand what the power can do, or doesn't have a relationship to people, average people who are going to be affected by something.
Yeah, I think all this is really important to get out, because there's both, again, what people on the science end might want to convey to the public, and then there's also sort of on the public end sort of what is the fascination with the scientists and what are the sort of the concerns and quandaries and things that people are interested in thinking about in relation to science. And obviously it's not just, you know, the separate thing where you have the scientists over here and pop culture over here. I mean, one of the things that's really fascinating, we're going to talk about this later in class, is, you know, if you talk to many people at MIT, and actually this is going to come up in relation to the next film we're going to see, but if you talk to many people around MIT of a certain generation, you know, they might have gotten interested in, you know, doing what they do because maybe they were really fascinated with Star Trek when they were kids, and they decided, you know, Aero-Astro, I mean, that's where I want to go. And so a lot of times if you go back and you talk to people, well, what originally got you interested in thinking about this, often people will refer back to sort of pop cultural images from when they were a kid about whether it's, you know, again, Star Trek, or actually this next, this is actually a good segue into this next video that we're going to see, because, you know, according to Chris, a number of people that he's talked to around MIT mentioned this. This series, Connections, that had been on the BBC as something that very much influenced them when they were younger, when they decided that they wanted to become scientists. So okay, so I'll use that as a segue into this. And so this series, Connections, that I just mentioned, it's mostly in that kind of genre of science as detective story. I mean, obviously it's also meant to be partly educational, but also science as detective story. It's a series that came out in the late 1970s. The narrator is this guy, James Burke. He was an Irishman who was trained at Oxford, and he became a science journalist at the BBC. And so this ended up becoming a very famous series on science and technology. And so we're going to watch part of the first episode of this. He was often described as being kind of the Sherlock Holmes of science. Okay, I'm not going to say any more than that. I'll just let you respond and see what you all.
And I'll just say, try to think about this film, and I mean all the other films that we've been seeing as well, but this one in particular, from the point of view of narrative strategies, keeping the audience engaged, and how that relates to the information that's being imparted.
And again, this series was an extremely popular series, and they had a lot of funding to do it, but extremely popular series that was quite influential.
Yeah, as Chris mentioned, if you talk to a lot of professors in their 40s who were, you know, who were teenagers when this came out, a lot of them will say, oh, I saw Connections on PBS when I was a kid, and that was it. I wanted to be an engineer or a scientist.
And again, this tendency, we often have a tendency to think of like, well, science is the serious stuff over here, and like the pop culture stuff is the not serious stuff over here. But again, as human beings, we get influenced by all of this stuff, right? And so the pop cultural representations become part of who we are and why we're interested in these questions to begin with, and they might be what pushes people into a certain direction to ask certain kinds of questions. So it's, in a way, it's kind of, well, we want to be thinking about both ends and the potential relationship that's out there as well. And we actually have a class later on in the semester that's specifically on science fiction. That's partly around these kind of very kinds of questions about sort of how science moves over into the pop culture realm and the influence sort of back and forth between science and the world of fiction.
But here you're going to see a science documentary that, among other things, is very heavily influenced by the world of fiction filmmaking. Okay?
Would you do me a favor? I'd like to stop talking for a minute, and when I do, take a look at the room you're in, and above all, at the man-made objects in that room that surround you, the television set, the lights, the phone, and so on. And ask yourself, what those objects do to your life just because they're there. Go ahead. Well, that is what this series is going to be all about. It's about the things that surround you in the modern world, and just because they're there, shape the way you think and behave, and why they exist in the form they do, and who or what was responsible for them existing at all. The search for those clues will take us all over the world and 12,000 years into the past, because it's in those strange places and in those long-gone centuries that the secret of the modern world lies. And you'll never believe the extraordinary things that led to us being the way we are today. Things like, for instance, why a 16th century doctor at the court of Queen Elizabeth did something that made it possible for you to watch this screen now. Or the fact that because 18th century merchants were worried about ships' bottoms, you have nylon to wear. Or why a group of French monks and their involvement with sheep rearing helped to give the modern world the computer. Or what medieval Europeans did with their fire in winter that led to motor car manufacture. The story of the events and the people who, over centuries, came together to bring us in from the cold and to wrap us in a warm blanket of technology is a matter of vital importance, since more and more of that technology infiltrates every aspect of our lives. It's become a life support system without which we can't survive. And yet, how much of it do we understand? Do I bother myself with the reality of what happens when I get into a big steel box, press a button, and rise into the sky? Of course I don't.
Reactions, comments?
It's nice how it's like a reenactment, but it's like so like theatrical and it's like really interesting, even though
it's interesting, like the pace at which it's narrated. It's very fast and anxious, and like when he was talking about the count, like it wasn't necessarily counting down, but as the minutes were passing till the blackout was happening, it just like emphasized like how fast paced the city was, and then everything just stopped and it slowed down, and it was as if like time froze because technology wasn't, I don't know. So I kind of like the way they set that part up. That was interesting.
Other reactions, comments?
It's really powerful how it constantly takes things that the audience takes for granted and reveals them to be extraordinary and ephemeral and not kind of exoticizes them and shows them in their capacity of breaking down. So in ways there is kind of romantic notion of in the end everything, this one tiny little bit can make everything else fall apart, and it's it just looks like a fiction movie.
Yeah, so stylistically, right? So it's filmed as well, you also have to see the relationship between this one, this is the first episode, and some of the other episodes in the series. So this one focuses on New York City as the modern technological metropolis. A lot of the other episodes in the series travel to different parts of the world and different historical time periods. So it might start off, it might be about the development of the printing press, and it might go back to the Middle Ages, and then, but it's following some technology historically through time and how this technology triggered all these kinds of impacts. And so the idea is to take things that you would never expect and trace back its genealogy and to argue that, well, it was linked to this kind of technological transformation that happened in this part of the world in this time that you never would have suspected.
Basically, yeah, I mean, the thesis is just as an example, the second episode begins with the coining of money, the first money, several thousand, over 2,000 years ago, and traces this argument that the direct result of that was the development of the atomic bomb, and traces sort of a technological evolutionary connection argument from one to the other with multiple steps in between. So the connection in that instance is the connection between this one tiny accident of technology in one part of the world with the next one, with the next one, with the next one. So this is kind of an interesting thematic way of getting into it, because he's looking at a network and how one tiny piece of a network can have these massive repercussions across the network, which is exactly what he then says about technology throughout the rest of the series.
So there's two questions to be asked then. I mean, one, so once you know where the rest of the series is going, and then it's set up sort of as this detective series through time and across space, how do they convey aesthetically the sense that this is sort of a detective story? And if you think back, I mean, how many of you have watched old film noir movies? You know, the film noir genre, the old black and white, where, so the shots of him with half his face in shadow, wearing the overcoat. There's a lot of darkness in here, right? That's the old film noir style. So it's deliberately drawing on the earlier film noir style of the late 40s, or early 50s, if that's right chronologically, darkness in shadow, to convey that sense to audiences that would have been very familiar with that genre, the sense that, this is some dark, mysterious detective story that we're going to be, taking you on. So one question is about the kinds of aesthetic choices that they made to convey the kind of narrative that they wanted to convey about science, that this is a detective story. So that's one question. And then the other thing, as Chris was just describing sort of the relationship between the different episodes, it gets to this question about accuracy. I mean, so the way they have of doing this, so you start out with this transformation here, and it has these incredible repercussions way over here, and then one of the questions that we kind of always have about the series is like, how much does sort of it ended up being sort of just so stories, and I mean, can you really kind of do that kind of, that kind of linking in quite the way that it does?
They're all very cool and interesting connections, but the question is, at what point are they serving a narrative, and at what point are they really interested?
Not making any kind of logical connection, but they're just sort of asserting a connection because it's good thematically, or narratively speaking.
But let's take a quick break. So we have the entire series of this in the DD Lab, if anybody's interested. I mean, they do make these very compelling stories, and whether they're just so stories, as Chris said, or whether they actually have something legit to say about how one technology feeds another, is probably a bit of both. It's probably kind of a mix of narrative flourish and substance.
But certainly they're fun to watch, and they were, as we mentioned, very influential in getting certain people to be interested in these kinds of questions and want to explore them.
Well, and I think in how people think about science and technology, and in a kind of an evolutionary way.
So at this point, any final comments on? Any final comments on connections?
I think it's just funny how, like, whenever there's a mystery movie, they always, like, it has to be like someone British or with an accent.
Right, exactly.
And it kind of like dark and maybe like damp sort of environments.
Yeah, exactly. And what's funny, one of the things that I think is absolutely hysterical, well, he has an overcoat on this, so you don't see it a lot, but he always wears this tan leisure suit. And so you go through all the episodes, he's always got the tan leisure suit on. So it's like that's one of the things that they use as an element of continuity throughout a lot of the videos. But as you say, the British accent, the kind of collar turned up, the film noir lighting. So again, through the various kinds of aesthetic choices and how people are dressed, what kinds of things get conveyed when you go to make your final projects? How do those kinds of aesthetic elements affect the kind of narrative that's going to end up being told? Okay, so just to sort of summarize some of this up. So one of the things we've been wanting to think about here is the question, or at least get out on the table, what kinds of narratives have commonly been told about science through documentary film? And there's been certain genres of documentary filmmaking about science that have been more common than others. For example, this kind of detective version or the educational film or whatever it is. But one of the other questions that we want to throw out is what kinds of narratives about science have not been commonly told, right? And I think there's a lot of other narratives out there about science and technology that haven't necessarily been told a whole lot. And so Chris and I, when we were thinking about setting up this class, I mean, one of the things that we tried to think about was sort of the direct cinema style, which we're going to talk about in a couple weeks. But if you think again back to that film Primary, where it's sort of like handheld cameras focusing on the action moving around, it's much rarer, for example, to see films made about sort of science and technology that draw upon those kinds of techniques compared to some others, or certain kinds of narratives that would come out of that kind of style of filmmaking. So one of the things that we want you to be thinking about through the course of this class is, okay, so there's the more common narratives that get told about science, and those might be very compelling, and you might very well want to draw on a final project that draws on some of those kinds of genres. Or you might also want to be thinking about what kinds of stories about science haven't been told as much that maybe I want to tell. Okay? So we want to kind of keep it all open to you and get you thinking about all of those. And the way we tried to set up the class is that throughout the course, you're going to be exposed to lots of different kinds of documentary filmmaking techniques, as well as a whole range of different kinds of narrative styles for talking about science and documentary. So the idea is to kind of give you a broad toolkit, okay? Both in terms of the kinds of narratives you might want to use or you might want to be telling, but also in terms of the kinds of techniques or styles of shooting that you might want to engage in. So the idea is to give you this, present this kind of whole range of things, and then this is your toolbox. And you get to decide what kind of story do you want to tell, and in order to tell that story, what kinds of tools do you want to use? What kind of narrative do you want to convey? What kind of narrative best gets at what you want to get across? Okay, so that is the idea for that. Anything to add on to that? Or?
No, I think that's a good summary.
Okay, so then before we end, then the last little thing that we want to do is just to talk a bit more about your final project so that you're thinking more about that. Again, I know, so Sabrina and Jessica and Katerina, and both of you were also at the DV Lab screenings, right, at the museum? So I don't know if there was sort of any reaction to those things that you thought were interesting as topics or narratives or things to potentially explore, or things that you might have thought would have been interesting, kinds of projects that weren't necessarily, you didn't necessarily be made. Anyway, any kind of responses to the ones that you saw, or if you just want to sort of skip to what you're potentially interested in doing. I don't know how much thought you've put into what you'd eventually
obviously this
like
is
to
very
do.
casual at this point. There is kind of a formal process later in the class of people presenting ideas and being able to sort of pick between several ideas, hopefully, so that you don't have to sort of settle very, very quickly on something.
Right. So right at this stage now, we just want sort of preliminary just to get you starting to think about stuff. And even if you have the vaguest idea, or maybe you don't even have any idea, I mean, any of that's okay, but I'm just wondering what you're potentially thinking about doing. And something else to think about is, again, this is a class, it's not film school. Right? You don't have massive amounts of time. Also, you have to be thinking about, if you want to tell a particular story, do you have enough time to be able to tell that story? Right? So we're not asking you to do these massive projects. And keep in mind, again, that the DV Lab videos that you saw, students worked on it one semester, but then they also had a half-class follow-up where they just worked on whatever project that they were doing.
Most of them came out of that. There were
a few of them were just from few were just from the first semester. But for your final project, so we're not expecting some half-hour piece. In fact, we would encourage people to keep it small. How would you?
Well, time-wise, certainly, probably under 10 minutes, realistically.
Yeah. Somewhere between 2 and 10 minutes.
Some of the ones we saw on Friday were longer, but again, they had longer to work on them.
Mm-hmm. I think it was interesting to see, the contrast between Tom's piece and Emily's piece. And I was trying to think where I want to situate myself along this continuum, just go somewhere and shoot everything, and trying to get to shoot interesting things, and people saying things that have some kind of, powerful narrative input in themselves, and then they're getting a lot of material, which is also kind of the point, and then you have this incredible editing problem, and I think Tom went through a completely different process also for the nature of the questions he was asking, the stories he wanted to tell. He had to completely construct everything and basically have actors, and Tom was about the controversy, so he had the guy on Skype and the other PhD student talking about the lab. And
the electron force microscopy lab with the conflict within. And Emily's piece at the end, hers was one about sort of, the cows, the agricultural fair. And Ty, you weren't there, but so the first piece is much more interview-based, talking about this controversy within the lab. And we could raise, there were certain, the kind of question too about what kinds of things can you get access to or not, and he ended up having reenactments because he couldn't get access to certain kinds of things, which we should talk about. And then Emily's piece, much more sort of observational style, where it's more sort of kind of quietly going around with the camera and just watching what people are doing.
There was actually a strong similarity to the two pieces in the origination, however, because both of them started out with an idea, with an abstract idea, not a story or a profile of a person. Tom wanted to talk about some fairly abstract things about imaging and what images mean and the relationship between something you see and evidence, and also to start to take a look at this controversy which had happened in the past. The people had left MIT except for one person. He had no material on it, no footage or anything. So he had to find a story to put all of that stuff on and create it as he went along. And Emily basically went to the fair with this idea that she wanted to shoot things that involved animal-human interactions. And she had to find a story in the edit room. She just shot for 3 or 4 days, shot a lot of material, and found a really nice, interesting narrative with all of these kind of connections that get made through the film. So again, the idea in both situations was that they didn't have a strong narrative like a process or a profile of a person or a competition. A lot of the things that we were just talking about, they had to find those things as they went along.
What Chris means is that some of this detective story, it has intrinsic to it a certain kind of narrative arc, but if you don't or of a competition, if you film a competition, that has its own kind of narrative arc built into it. But if you're filming a topic that doesn't have a kind of drama that's automatically built into the topic, then you have to create the narrative thread. Well, and so you do it through editing or through other kinds of means. An
example of something that has a built-in narrative arc, last year, one of the students for an earlier project shot a very interesting, fun little film about the pie eating contest at Pie Day. And it was great. People sit down, who's going to win, pies, it's fun, there's all sorts of interesting oh no, not the pie eating contest. The naming the numbers of pie. How many places of pie can you name? And there's pie at the end of it. But it's a competition. There are interesting, quirky characters and moments. You get kind of involved in who's going to win. Somebody wins, and there's a denouement. So there's a narrative built into the story, and she went in knowing what the narrative was going to be. Right, and somebody also did a very fun piece on student elections, people running for office.
So, and then somebody wins, right? So again, there's closure to it. So there's certain kinds of topics you can pick that are easier in some sense because they have built into them, again, a certain kind of drama. And if you decide you want to do a topic that might be incredibly fascinating and wonderful to do that doesn't have that, again, it just means you just have to do some additional kind of work in terms of thinking about how you're going to draw it or create some kind of story. Because ultimately, in order for anybody to want to watch something, you have to have some kind of story be there. You have to be saying something with what it is that you shoot. Okay? And maybe not at the beginning, maybe not when you start the shooting process. I mean, again, people come to these things in very different kinds of ways. A kind of a very anthropological approach to shooting would be, okay, well, I'm interested in this topic, kind of like Emily with the agricultural fair. I'm interested in animal-human interactions, but I'm not going to assume I'm not going to assume anything about what I'm going to find. I'm just going to go and shoot. And I'm going to see. And I'm going to think about it. And then I've got all this footage. And I'm going to sort of ponder that. Well, what was that about? And then through the process of kind of pondering that, you decide like, oh, kind of this is kind of what this is about. And you start to put together the visual images in a way that kind of tell that story. So some people have it more kind of as a process of exploration in the world, and you pull it out, and others kind of have something either more built into the event itself, or people have some kind of story that they want to tell more clearly, and they're looking to illustrate it.
And then the other thing I think we'd both encourage you to think about are stories of science and technology that are non-traditional. I mean, there are the lab stories, but we define science and technology pretty broadly. In fact, really broadly. You know, the puppet theater is not exactly, I mean, there's, again, a craft portion to what they're doing, craft technology, but it's a pretty broad interpretation of what a science or technology-related film would be. And there are a lot of really interesting things going on at MIT right now that we would both encourage you to think about. There's the Festival of Art, Science, and Technology, which is just filled with really interesting events and projects and happenings between now and the end of the semester. There are multiple possibilities there for a film. Which isn't to say that a fantastic film about lab research is not a great way to go too.
Which could be really terrific. There's also the 150th is going on now too, so you could do a film about MIT reflecting on itself at 150th. You know, so it doesn't have to be MIT's narrative about itself, but it could be sort of your take on what they're presenting as that. I'm just trying to throw out other things that are sort of out there going around that are happening right now. Things that are happening right now are obviously easier to shoot. I mean, we did a film that Chris did that I helped out on. Chris, I think I mentioned this in first class. He did a film about a documentary about the 1979 nuclear accident at 3 Mile Island. So we were making the film much after the accident, so there's interviews with all the people in the area, but there's also a strong reliance on archival footage and getting people to talk about the past, and so the film becomes very much about memory as well. So if you want to get at a historical topic, there's a whole other range of issues that you kind of have to deal with. If it's stuff that's not happening in the current moment, how do you tell that story? If it's something that's happening right now, right? I mean, you know, that's something that's really well suited to, say, the direct cinema style, which is a very kind of observational style where you just go out and sort of explore that thing that's going on. But if you want to do something about the past, you can do something about Doc Edgerton. You can do something about, I mean, God knows what. I mean, there's a zillion topics. And
just, I think, as we've sort of mentioned before, film tends to love action. It loves movement. It loves activity. Action films is not just what we think of as action films. I mean, films are about actions. And that isn't to say that you can't start with a very, very abstract idea, but you just need to kind of come up with a strategy for turning that abstract idea into actions. And if you think about the clip of Fast, Cheap, and Out of Control that we saw that has this very, very abstract idea about groups and networks and controlling nature, and Rodney Brooks, it's brought alive with all of this found footage, archival footage, cartoons, all of this stuff sort of montaged together, edited together in a very sort of interesting way. Emily had a very abstract idea, but what was great was that she had people doing stuff, competing in various competitions. This fair it was incredibly visual, movement, lots of animals running around. So it became very easy for her to turn that abstract idea into something that was film friendly. Tom, of course, had to use actors. That was his choice to make turn his abstract idea and his thing that happened in the past into actions.
Well, and there was the related issue, which we should just at least mention too, that there's the issue of access and what you can get permission for. And again, there's permission forms that when you go to do interviews, you have to get permission from people when you do this. And one of the issues about I mean, we were sort of strongly encouraging people last semester, again, to kind of go out and try to explore new narratives about science. And, you know, the idea of sort of doing a more kind of focusing on science's process and getting some of the day-to-day of how science and engineering actually plays out in a day-to-day way is really fascinating, something that hasn't been done that much. But there's also, if you choose to go that route, which I think is a really fabulous route to go, and I'd encourage you, I mean, that's one route that could be really cool to do. But one of the difficulties with that students last semester found out was that you have to think about, there might be a lot of issues around permissions, for example. Right? So what would happen was that a number of the students last semester, they found some totally cool thing that was happening in some lab on campus. And they had friends who were graduate students. The graduate students were like, yeah, this is great. And maybe they did preliminary interviews with that grad student, and there's fantastic stuff. But then they had to ask the PI of that graduate student, and the PI said no. Because, you know, there's worry, you know, in certain labs, understandably, that if stuff gets out before it's been published, it's kind of a pre-publication kind of, you know, what's going on inside the lab is going to be disseminated in a way that they don't necessarily want if it hasn't necessarily been published yet. And then there's also, I mean, for obvious reasons, people like to control the images of themselves, right? So if you're the head of a lab and you've got funding sources, you know, it's not surprising that people sort of want to control the image that's going to come out of their laboratory, the same way that, you know, at MIT in general, there's sometimes a desire to control, well, what's the image of MIT that's going to come out. So that doesn't mean you can't get permission to do those kinds of things, but it might take longer than you think. So that was one of the things that sort of stuck some of the students,
don't assume
that
you
slowed
can
them
get
down
permission.
a bit.
Think about who you need to give you the final say that you can do a project if it involves things like that.
And really explain to them what you're planning on doing, what you're not planning on doing. You know, we've been putting the ones the class videos that we've had permissions for, we've put them up online, but you don't necessarily have to do that. If you want to just shoot it as an exercise for yourself, you can tell them that it's not going to go up anywhere beyond that, and you know, and then we abide by that.
Although we would, for your final projects, we would strongly encourage you to try to get the necessary permissions so that it can be published online.
Yeah, because
you know, it's just better for you.
And yeah, if you do a final project and you put a ton of work into it,
you want to be able to share it.
Yeah, you're going to be sad then at the end if you can't show it to anybody other than the class.
But there are also creative workarounds. I mean, for those of you who were there Friday night, Max Dunitz did the film about the researcher / stand-up comic, and basically he was not allowed to say what lab he worked in, what exactly he did, and
because he was feeding cocaine to rats, and so they didn't want the lab didn't want that discussed.
So
although he had all this YouTube.
Right, so he discussed it without talking about exactly what school he went to, which was an MIT, what lab he worked in, any of his coworkers, any of that. All of that was out of the
So it was made a joke out of, which in a way that worked. So this is something that's different for those of us who are used to doing, you know, I mean, those of us who sort of work in the social sciences, the way we usually handle this in our written work is that we use pseudonyms. That's how we give protection to the people that we do our research on, is we use pseudonyms. So, you know, so that people have privacy and there's not, you know, harmful outcomes to them in the end. But when you're doing video work, you can't do that. So that imposes certain kinds of constraints in terms of what stories you can tell or how you would do it, in the way that Tom dealt with that, because he was dealing with controversies within a lab, right, that were very, you know, they were, you know, passions were strong around those controversies, and it stood to affect people's reputations, and it could have, you know, some of the graduate students felt like, well, it could have affected their reputation. It would make it difficult for them to get work afterwards. So the way that he dealt with that is that he had his friends reenact those scenes, and it was, you know, and all of his friends were, you know, students who had worked in labs and experienced something different. So it was actually kind of this fun thing where they got to sort of act out like the drama within their own lab groups. So it ended up being a really fun kind of reflection on what they actually do. But that was a really creative way he got around that issue.
And the other thing is he embargoed the film all of last year, and
until the last person left MIT who had been involved in it.
And now it's on the front page of Tech TV as of today, because we can finally show it because everybody's left MIT. So
yeah. Anyway, so we've done a lot of talking now, but do any of you have any ideas yet on what potentially you might want to do, or whether something might be feasible?
After seeing the videos, I realized like it would have been really helpful, according to a lot of them, to work with another person and partner. So Ty and I were thinking of doing a film about ROTC and like the MIT engineers. ROTC is the Reserve Officer Training Corps. Yeah. And so like it would show how their students are not only like preparing to be soldiers, but also like their engineering and like science, like educational background, and like how they balance the two.
Yeah, that's a fascinating topic. Just to clarify one thing, everybody does have to do their own film project at the end, but you can still work together. I mean, what Tom was talking about was when the idea is, and this is the way sort of it commonly works at film school, is that when people are working on their projects, you draw on your classmates to help you to do sound, or to help while you're interviewing. Maybe somebody does the camera because you need to be able to talk and interact. So part of the idea is that you kind of build a cohort as time goes on, and other people help you, and then you help them in turn. And it really does help the whole quality of the filmmaking process. So there is this kind of collaborative, collective aspect to making this stuff that we would really encourage.
So we would encourage you to work in teams, but to do
so the outcome would have to be
projects.
Separate to be graded. It would have to be graded separately. But you can even do, I mean,
you could even do two related projects.
Yeah, exactly. I mean, so you could do the same topic if you wanted and have two different takes on it, or but two different visual products at the end.
So if you both did films on ROTC and shared a lot of the camera duties, you would still need to edit your own projects.
Because part of it, in terms of grading, to be able to sort of, that people, sort of got the basics of sort of how to shoot, how to edit. Because again, we don't want to, as we said in the very first class, we don't want to have to grade people on just the final product and how aesthetically, good it is, because people might be coming from very different backgrounds. But so we also want to do a fair amount of the grading in terms of amount of effort that people put into. And if it's done collaboratively, we can't tell, if one person did 3/4 of the work and one person did a quarter, it's harder for us to judge in that kind of way.
You could certainly shoot collaboratively, and we would strongly encourage everybody to do that.
Yeah.
Does that make sense, or is that okay?
So, let's say we have a topic in mind, but we don't know much about it, so we don't know what kind of stories there are there. So what's the best way? Would you just go and start filming, and like I realized the other day we were filming just a very basic kind of scene of like somebody chopping things, then there was a story to it. I mean, there was a kind of relationship, very essential relationship with vegetables, which I wouldn't have thought about until when I could hear the sounds and the vegetables being eaten and like scenes, like the beauty of, and it really came out only when I was looking at it through the camera. Well, so, or should you kind of think about it more before starting to?
Well, there's sort of an interesting answer which comes out of the technology that we're using. The way to begin a project like some of these projects are, traditionally would have been to go do some pre-interviews, to do a site visit. If you're doing something on a lab, you go visit the lab without a camera, you interview the researchers, you sort of just get the lay of the land, you look for stories. And the advantage of that is that they see you as a human being before they see you as a camera. And that's really, really important, because you make a human connection before you jump up and take out the camera and stick it in their face and say, be in my movie. But on the other hand, the great thing about these cameras is that they're so small that you can just throw them in your bag and bring them. And so what I often do, and what I would think that you might want to consider, is do exactly what I just said. Set up a site visit with no camera. Go in and meet the people. But if you have the camera in your bag and you're sensitive enough and have your sort of antenna out enough about what's going on, at some point it may be okay and just completely natural for you to take out the camera. And you obviously need to ask before you do it. You need to make sure that you've kind of established a rapport and that everything is good and they're enthusiastic and interested. And you'll want to listen to yourself and your own instincts about whether or not you want to shoot, because as you said, you start seeing things really differently through the camera. and you have ideas that you wouldn't have necessarily had if you're just talking to the people. And I've been on the other side of that coin where I'm on a site visit or some kind of pre-production thing, and I realize, oh my God, why didn't I bring the camera? There's some amazing stuff happening here. Why can't I shoot it? But you just have to be aware that if you walk in with a camera right off the bat, on your shoulder, ready to go, you may alienate the people, and it's kind of a rude way of introducing yourself.
Yeah.
So this gives you the best of both worlds. Go make a site visit. Don't plan to film, but have the camera in your bag. And if the moment is right and the rapport is good and something really fascinating is happening, you can ask and film.
And you know, kind of on the even more extreme end from that, say people with anthropological training who go to make documentary films, sometimes they'll spend a year before they even take out a camera. And depending on where you are and if what's going on is really socially sensitive, that people will spend that time just building relationships, knowing what's going on, developing that sense of relationship and trust with people, so that when they actually go and pull out the camera, it's a completely different product in the end, because you can feel the kind of interaction between the people who are being filmed and the filmmaker, and it's completely different than somebody who sort of just came in for, a couple days to shoot something. It's a totally different product. And so I can try to remember now what films we're showing you for the ethnographic film section, but maybe I'll switch it a bit and try to pull out some that sort of convey that kind of long-term relationship. So in some cases, when people have the time and the money and the ability to do it, people will spend a year or so in advance just building relationships before they ever start filming. So obviously you can't do that.
Well, the other thing is too that
but just to emphasize the importance of the social relationships and establishing the comfort level of the people that you're working with is really crucial.
That's the key. But I was going to say, even there has been a shift, I think, with video, because video is so cheap and the cameras are so small and so ubiquitous that you still spend the year or more building the relationships, but you can introduce the camera sooner. And then the camera just kind of disappears eventually. Mm-hmm. So, but it's the same principle. You've got to be seen as a human being and have that human relationship before you become a camera. And if you do it at the right pace, or the best pace you possibly can, given your time and your budget and your schedule, the camera will be more likely to disappear.
And this is why it's better often to have two people. If you do have, I mean, some of you might be doing sit-down interviews, and some of you might be doing handheld, where you want it to be about action, about movement, and you don't want to do sit-down interviews. But if you do decide you want to do, well, either way you do it. If you're going to be talking to people and have them talking back directly to the camera, with comfort level, people are often much more comfortable talking again to. I'd be much more comfortable talking to you if you didn't have a camera in my face. So this is again where it's really helpful to team up. That if you have somebody else going with you, maybe somebody else could help do the camera work, and maybe Katerina's filming me, but I'm talking to you. And you're really paying attention to me because you're not worrying about the camera and whether it's exposed right, and and all these other kinds of questions. And we can establish a certain kind of relationship that somebody else can film, and it makes it a more intimate interaction. So this is again where it's helpful to have potentially have somebody else go with you. So you as the filmmaker, you might either choose that you would rather do the filming and have the other person do the interviewing, or vice versa. But it's often helpful to have somebody just kind of be about the social relationship part, and somebody else focusing on the technical ends, like do we have again the exposure right and the focus right, and are all our wires all tangled up in a mess, and we're broken batteries, or have someone focusing on that end.
Just one last thing on this topic. A lot of really interesting work has come out of this class when people have filmed their friends, and the reason for that is that people are obviously very comfortable with each other. There's a lot of trust if you're filming your friends. So some great work has happened. The downside of that is that you're not taking yourself out of a comfort zone as a filmmaker. You're sort of shooting fish in a barrel. So I have kind of mixed feelings about that, and I would say about that there are a number of intermediary steps before you do your final project. There are a lot of small things along the way, and you might experiment with kind of both sides of that coin. Doing a topic and filming people that you know very well, and then kind of taking yourself out of that comfort zone.